I want to just talk for a moment about my aims here, to grow our group's capacity to image living systems at work, which is a little different than imagine, but to actually have an image of a real living system in our mind, to reveal what's often hidden to us, and to uplift the essential work of other species and ask us to reconsider how we value that work. And to create conditions, even in this short time together, that activate our will as a group, our determination to take action, etc., and to strengthen our discernment, our decision-making, so that humans can participate meaningfully in the work of living systems. And for today, how we're going to work and learn together, that when you're in a breakout group or in the chat, there's no need to introduce yourselves in the formal sense. We will get to know each other as we work together, either in the large group or in smaller breakout rooms. But I'd like you to assume that everyone here is already impressed with what you've done with your life and already likes you. This is a great, I would suggest that you do this all the time in your life. You'll find that life goes better if you do that. And so I'm just trying to get my view here so I can see my slide here. And don't accept or reject anything that you hear me say or other people say until you test it with your own experience. I really strongly suggest approaching life this way, because it's that lived experience in the land, and it often takes more than one experience to understand things. That is how we learn best, with our own senses, and also even testing an idea in your mind. Being able to image a living system helps to ground it. It also will make you better at explaining it to other folks if you can speak from experience. We're here even in this short time as resources for each other. So you can learn from each person here if you know what you're listening for. There are no experts, including me. Everyone is intelligent, and my role is simply to be a resource to the group as a whole. And finally, you'll learn more in the next couple of hours and in life if your aim is to ask better and better questions and engage other people in thinking about those questions, rather than striving to always find the answer or prove what's right and wrong. So we're going to start today with an exercise, and I'd like you to take some notes as you go through these questions. And this is what I was talking about imaging rather than imagining, to actually create an image in your mind of a real time when you saw rain falling in a place that you know well. Where does the water go? You can take a snapshot of this, either a screen share, a screen snapshot, or just use your camera if you have a camera to take a picture if you want to save this. What plants or other things does it touch as it falls? How much of the water enters the ground versus running off sideways? And then kind of look around you in that image you have, the places where the water is soaking in versus not. And what conditions are needed for land to soak up water? What conditions in terms of plant and vegetation, soil structure, land features, temperatures? So you might think of the same spot under different conditions, different times of year. What happens to the water that's soaked up later? So where is it a few hours, days, weeks, or even months later? And what happens to the water that runs off? Where does it go, and what influence does it have? And what effect does that rain have on the minerals, the geology, the structure and chemistry of the land system? What effect does it have on the life and biology of the land, the physics or temperature or weather, climate, and the economy, and I didn't add this, but the well-being and health of the farm, the town, the region? So I'm going to give you 2 minutes or so to make some notes about this. And I really asking people to do the exercise, not to make it more like school, but because this is actually how we get all of our minds pointed in the same direction and have it be grounded in an experience rather than it just being me telling you something. So we start to get an image of how the soil sponge works or doesn't work in different parts of the world. So especially those of you from outside of the UK, it might be helpful to hear some of your images in particular, but I invite anyone to put that into the chat. What are you noticing as you think through these questions? Yes, so as you look through the chat, you can start seeing that this is like we're developing a picture that we can work from. Yes, and Ilana, same thing here, that this, if you're in a region where there's snow right now, which it's snowing here as well. I don't know where you are, Ilana, but that water is held there, and it may soak into the ground slowly in the spring if the snow melts slowly, or as we've had happen in Vermont often, including recently, if it melts too quickly, then you may have flooding. Same thing with the snow melt on top of mountains, coming down into valleys. Okay, feel free to keep posting those if you like. I'm gonna go back to the slides and give you a bit of an image from here with some pictures. So this is near my house. A road called Buzzell Bridge Road that takes you down to the Ompompanoosuc River. We'll take a little walk together with my dog. And here's the river. It's a beautiful river that kind of nice depth, nice width, very human scale in terms of being able to play in it and swim in it and throw snowballs in the winter. In the spring, it gets kind of wild, just what we were talking about, if the snow melts very quickly. And we do have kind of raging rivers and sometimes floods. But in 2011, we had a different kind of a flood. We had a lot of rain in a very short time, and it was not in the spring. It was actually in late summer. And this river and all of the rivers in the States and all the streams in Vermont, I'm in the United States in Vermont, northeastern US, they jumped out of their tracks, and we lost hundreds of miles of roads and hundreds of bridges. And I was at the time writing a book called The Ecology of Care about resilience in the healthcare system, and not very focused on climate change. I kind of felt like that was happening in other parts of the world, and that Vermont would be nice if it was a little warmer, as many of you in the UK may feel as well. But and to me, it was very abstract thinking about carbon. But after this flood, I started to understand that climate change was much more about water than I had realized, and that it's about where the water is and what it's doing, and is there enough or too much, and is it is the snow melting quickly or slowly? Is the rain falling in big chunks, all at once, or is it spread out evenly across the continent? As someone who had spent so much time, both as a young person and as an adult, playing in rivers and streams, to me, water has been fascinating. And that was my hook into being intrigued by climate change. And my book, The Ecology of Care, expanded to really start thinking about that. And everywhere I drove after this flood, all I could think about was what happens with the next big rain. And that's partly because in Vermont, all of the roads are built along what used to be deer paths through the woods, which were then horse paths through the woods and footpaths, and then turned into small dirt roads. And most of our roads are still dirt roads that go through the woods like this. And they all have streams next to them. So that's why we lost so many roads during that flood. But you'll notice here that where the damage was done was not where the vegetation was. It was in the places where there was no vegetation. So when my book came out, I turned my attention, actually I used to be a healthcare provider for 22 years, and turned my attention to water and soil health as public health. And the first thing I did was to start writing a curriculum, because I've always found in my life that the best way to learn is to teach. So I wrote some grants, started writing curriculum on understanding soil health and watershed function. And what I was learning as I was going along was it wasn't just about flooding, it wasn't just about drought, it was also about water quality. So this is our agricultural region up north, up just below Canada, with Lake Champlain. It looks beautiful from a distance, but when you get up close to the lake, often in some times of year, it looks like this, because the soil is not absorbing the water, and all of the chemicals are running off into, and manure, et cetera, is running into the lake and causing algal blooms, which as a public health person is also of great interest to me, because this can cause a lot of health effects. So I came out with this 150-page teaching manual, which is designed for people of all ages to use, and it's being used in about 60 countries, and Dora will post a link to that in the chat. And it's a free download, so feel free to do that. While I was writing an exercise called a walk in the rain, which we'll do a virtual version of that a little later, I got a call. I was not in town, and I got a call from my children's father saying, hey, you might want to know that something really crazy is happening here. And this was just a couple of years ago, back to this road. And this is when I came back from that trip. This is what it looked like. And the exercise I had been writing literally as this flood was happening was talking about following little trickles of water, kind of like we were maybe thinking in the beginning. But that flood took out my road down to the river. And so I was sort of personally affronted by that one because it was closed now for 2 years, closed to emergency vehicles, closed for swimming, closed for everything. And it became a very kind of post-apocalyptic thing. If you did walk down there to go for a swim, everything was in the wrong place. And it was deserted and sort of odd. So, and it took them 2 years and millions of dollars to repair this road. And we live in a town with only 2,500 people. So, so that kind of cost started coming into my mind, like, wow, this is really an economic impact, just the rebuilding from not having an effective soil sponge upstream. So one of the exercises that I developed as I was writing curriculum and working with farmers and high school students and kindergartners all over the world, or all over the US mostly, was this exercise of this flour versus bread as a way of looking at the soil sponge. So I take some flour, put it on a plate, and explain that is the sand, silt, and clay, the mineral portion of soil that we think of when we think of soil structure, and that is often taught as like that's what determines how water moves into soil, is the ratio of sand, silt, and clay. But if you have just sand, silt, and clay, we'll go down to the active version of this. If you just have sand, silt, and clay, then if you rain on this, what happens is there's nothing holding those little mineral particles together, and the water runs off the top. Anyone who's done any baking knows what that's going on there. The plant roots aren't getting any water down below. You're having a flood as all around the lower areas. As soon as that flood is over, though, you're back to having a drought. So drought and flood are really two sides of the same issue. You're also seeing a lot of that soil is running off the top and going into the water, along with any chemicals that are being used. And if you were to put that plate out in the hot sun, that's all going to dry on top, and it's going to form a crust. And so the next time it rains, even less is going to get in. But what happens if we add biology to that flower? It's a little bit different what's going on in soil, but the effect is very similar, that suddenly we have a structure that is not little particles, separate particles, but particles that are glued together into a sponge. And suddenly there's air, which is important for life underground to continue, and also make space for water to be absorbed. So when we rain on that landscape, about 10 times more water, if we just use the flour bread example, can be absorbed before it even starts coming out the bottom. And of course, here we've got just 3 slices of bread, but in a soil that could go many feet deep. And you can imagine with a structure like this, that's going down, it's being held underground for the plant roots for current and future use. It's like an in-soil reservoir. It's protecting the landscape from flooding. It's protecting it from drought. It's actually protective against wildfire, helping to create conditions for fungi that will break down dead plant matter that falls on the ground. And it's serving as this huge carbon-rich filter. So you see that the water that's coming out the bottom is now clean and clear. It's actually cleaner perhaps than when it fell from the air, because we now know that rain is carrying a lot of things with it. And it's being filtered both structurally, but also biologically. So the biology in there is actually breaking down any chemicals, et cetera, that may be in the water. So, and you don't have that crusting on top. The crusting is not just the drying of things and sticking together, but it's those little tiny particles moving sideways and filling in the holes. So, so that's not happening because everything's being held in place. And what we're not seeing in this picture is that how you get from that sand, silt, and clay to a real soil sponge is the plants. So nowadays when I do this, I'll often throw some little plants in the top of that bread. But we can see another version of it here. So this is actual soil, all from the same farm, same soil type. But on the right-hand side, they haven't used any of the soil health principles. So there's no cover crop. The soil is heavily tilled. They're using lots of pesticides. They're not leaving any mulch on the surface. There's no animals integrated in, and it's a monocrop. So on that far right side, you see that the jar down below is not accepting any of the water. So there's nothing, we've put 4 inches of water on here, and it's like a 4-inch pan, and nothing's gotten down to the bottom of the plant roots that would be growing there. But it's all run off, and it's taken a lot of the soil with it. So in the US, in Iowa, they find that to grow a bushel of corn loses a bushel of soil a year. And for soybeans, it's double that. So that is not a sustainable system. We can't be losing our most precious resource that way. But as you start implementing these soil health principles, you see moving to the left that more and more water is soaking in below, and less is running off. And the water is also getting filtered as it goes through. Here's another version of thinking about this. What's holding those together, all those mineral particles, are actually biofilms, so natural glues. We make them with our own bodies. Think about the snot that comes out of your nose. Think about an egg white. Think about snail slime, worm slime. All of these biological films that living things make, when they dry, are very water resistant. So the sponge, even if you think of a kitchen sponge, it's got to have a couple of different qualities. It has to have that porosity to accept the water, but it also can't fall apart when it's wet, right? If every time you stuck a sponge in your sink and it fell apart, you wouldn't be able to wash the dishes with it. So we have water resistance and water absorption in one living matrix here. So you see, you could leave these clumps of soil for like 24 hours and it would still stay together if it's a healthy soil. Whereas the one on the left, as soon as you put it into the water, it starts falling apart without those biofilms. So why should we care about the soil sponge? Well, drought protection is a major thing, and this is actually from the Karoo region in Africa, and these are both sheep farms, and the only real difference here is that the one on the left, they have managed the sheep so that they're mimicking the movement of a wild herd of animals, so that they're moving through the landscape, whereas on the right, they're just allowed to roam and graze where they like. And you can imagine that, first of all, there's obviously, you could grow a lot more food on the left-hand side, but there are also lots of other great things happening there. So we have different kinds of plants. The soil is covered and protected from the sun, a lot less, a lot cooler, if you can imagine standing barefoot on one side or the other. And it's actually going to be cooler above the plants as well, when those plants are transpiring and photosynthesizing, which we'll get into later. We talked about the in-soil reservoir. There's also local water cycling that we'll talk about later, that water it's kind of like a local multiplier in economics. It keeps coming back to the land. And the more life there is in the soil, there's more metabolic water. So when you drink water, that water comes through your body and you pee it out again. When things start eating each other in the soil food web underground, there is actually water created as they're metabolizing. And then refilling the aquifers, as we said, and other bodies of water from below with clean filtered water. Flood protection. This is one of the first places I visited when I was starting to try to understand what was going on these farms. This was in southeastern Saskatchewan in 2014. They had just had major flooding, and the crop fields were full of mud, and each farmer was digging a ditch to try to get the water to leave their farm, which was pissing off the farmers down the road. And all of the seeds were just rotting in the ground. But next door, where they had actually shifted back to turning the land into grassland, back to a more of a grazing system, or grazing integrated with cropping, the soil was a big soil sponge, and it had soaked up the water, and they didn't have the same issue at all. But even if you're doing, even if it's just a cropping system and not pasture, you can see here, I believe this was in Oklahoma in the US, that on the right-hand side, conventional tillage without cover crops, and on the left is no-till and cover crops. And it looks like snow on the right, but that's water that's sitting there. Another benefit is like with that original picture of that lake. This is now we're down in the ocean. This is actually not a fence line photo. I wish it was, but it looks similar to that in that that's the boundary layer of an algal bloom, of a dead zone in the ocean, and that's from not having soil sponge all the way up the Mississippi River. So we're getting the nutrient runoff down into the ocean. Clean air is a huge thing. So we didn't do this in that demo that I showed, but often I'll pick up the first plate with a flower and blow on it as if a big wind came along. And of course that soil goes right into the air. This is a picture from the Dust Bowl, when this soil blew all the way across the US from the Midwest to the halls of Congress, darkened the windows of Congress while they were debating about whether they should establish a soil conservation service, which they did. Thank you for that. Thank you for that particular gust of wind. But you can imagine the respiratory issues that develop when you have dust storms like this. And now, increasingly, it's not just the soil, but for example, in Texas, and I know there's at least one person here from Texas, when you get a dust storm, it's bringing those antibiotic-resistant bacteria from the feedlots into the air. So there's already things just in soil itself that can cause a lot of respiratory issues. But when you're getting bacteria, when you're getting chemicals, glyphosate, et cetera, that's really problematic. Biodiversity is a huge thing here, because one of the ways that we've learned to quickly build a soil sponge is simply to diversify the crops. And I don't mean rotating crops like one after another. I mean actually diversifying in one field, having more crops growing together helps to kickstart the biology in a way that will grow the sponge more quickly. So that having that biodiversity in the cropland, and this is not cropland, this is more of a natural system down by my river again, but that's how nature grows a sponge, and that's how nature functions best, is having those relationships between things that then brings in a diversity of insects, which then balances out those predator and pest relationships, that then brings in more birds and owls and other animals that will eat the so-called pests, and we just get a lot more beauty in the land. So one of the things that I hear a lot is farmers who got into this because they're up against the wall financially, but when they start seeing what's happening on their farms, they really fall in love with the land again and with the way that land works when it's working. Cooling of soils is really key. These degrees are in Fahrenheit, but you can see just same farm, same day, just having that cover crop and that mulch layer is tremendous difference in the temperature of the soil. And then cooling of the local climate. Somebody's got their is unmuted, so just so you know, I'm not hearing a lot, but just heard a little something. The air temperature above a green transpiring landscape, here we're in Celsius, is typically cooler than bare soil by a mean difference of 2.3 degrees Celsius and 11.7 degrees Celsius cooler than pavement. But that kind of cooling, which is a latent heat flux cooling, requires transpiration to be happening. That means the plants are kind of sweating, similar to the way we evapotranspire water on a hot day. But that requires a consistent supply of water at the root zone. So that can only happen when we have that deeper soil reservoir and a healthy soil sponge. And then there's this really interesting question that a lot of us are looking at right now is, if we had enough of that happening on a global scale, could that cool the global climate? So a scientist that I work with, Walter Jena, has calculated that as little as a 5% increase in transpiration through leaf area, through acreage of green, or through the length of the green season. Because when you have a deeper sponge in a dry seasonal rainfall area, the green season will lengthen by having that soil sponge. So as little as a 5% increase could be enough to quickly and effectively cool the planet through latent heat fluxes. So lots of things we need to think about, of like, is this really, how real is this? But it's an intriguing idea, and we do absolutely know that even if this is not true, that we can cool our local regions, and there's cities and other places that are already working on that. However, I ran this by another scientist that I work with who wrote the textbook Environmental Biophysics from University of Wisconsin. And he actually affirmed these numbers just as a sort of a hypothesis. But he wanted to say, well, he said, well, yes, but we're not necessarily going to be able to increase transpiration everywhere. So what if we just think about agricultural land? And he figured that a 23% increase in transpiration on agricultural land could actually offset that 0.6 degrees Celsius increase we've had, which may actually be even a little higher since I typed that number in. But what does that mean? So what would that mean to increase transpiration? Well, most cropland in the United States right now doesn't use cover crops. So simply increasing the use of cover crops certainly could provide a 23% increase in transpiration. Now, plants aren't transpiring all the time. They're only doing that when they're photosynthesizing and when they have enough of a soil sponge below them. But this is not a huge ask. You know, this is not a huge change in the way that we do things. It's simply letting go of that bare fallow period. And it's also, we are seeing now in Andhra Pradesh, India, there's a project that I'm working on there where there are 800,000 smallholder farmers who have adopted regenerative agriculture and are working with some of these ideas to have a much longer green season. So they are planting seeds before the seasonal rains. They're calling it pre-monsoon dry sowing, and they're getting a full crop before the rains even come, which is having a huge impact on their income, but it's also providing a lot of cooling and time when that soil sponge can start to grow, because soil sponge is really forming best when there are green plants on the surface. So because those plants are feeding the underground life, those exudates, those sugars and other things that they're making are being fed out through their roots. And that's how that whole biofilm and sticking those soil particles together gets kick-started. So the soil sponge creation, it can help to create a longer green season, but a longer green season also creates more soil sponge. So once we get started on this, it could happen very quickly. Okay, I think we're gonna just stop for a moment there. And how are we doing time? Okay, we've got some good time left. So I'm going to, why don't we take like a 1 minute bio break here. Get up and stretch and move and dance around a little bit and get yourself a glass of water or empty out the glass of water you had when we started. And then we will come back and we'll do another little exercise together. Okay. Yes, a link to the work in Andhra Pradesh. Let me see. There's some great videos. Don't have access to them quickly, but I will try to find those while I'm going to send you off into a breakout group in a moment. Dora, if you could set up breakout groups, all 50 of them, so we'll get as few people as possible in each one. Let's see, will that 50 would, yes, 50 is great. That'll be about 3 or 4 people per room. And I am going to share my screen with another little exercise. Okay, how do you explain what's needed to address climate change? What do you see as a central issue to be addressed? What language do you use to express it? What initiatives do you support and why? And then I'm going to add a question here, which is, given what you just saw, does that change anything in your view? And can you kind of go from how you've been thinking about climate change to maybe how you might start thinking about it? What new questions might you explore? And how might you change your aim? How might your aim have shifted from your previous, maybe it was draw down soil carbon, and now it's something that's a little bit more complex or interesting than that, even though that's very interesting in and of itself. So if you can take that into the breakout rooms, maybe make a few notes right now, since I don't have all the questions on this slide. So what do you see as a central issue of climate change to be addressed? What language have you been using to express it? What initiatives have you been supporting and why? And then how might you change that based on what you just heard? What's changing for you in your understanding? And how might you shift your aim just slightly, given that? Okay, Jora, if you want to unmute and just let me know where you're at with the breakout rooms, that would be great.
I'm ready to go.
Oh, perfect. Okay, so we're just going to do about 5 minutes. Don't waste time introducing yourselves. Introduce yourselves by your thinking. You can feel free to say where you are in the world. Go ahead and have fun, and we'll see you back here in about 5 minutes. Welcome back, everyone. I would love it if you would, again, just post a little in the chat of any new thinking that came to you, where your minds are at right now. What are your new questions or your new aims based on what you're thinking about now?
I see there's a hand up from Mary Cade. I was happy to share mine, but perhaps she's first.
Okay, I was actually going to invite people to, well, yeah, sure. Let's take a few people with voices. Petra, go ahead, but also so that we can hear from more people, for those who aren't speaking, to just put it in the chat.
Yes, my name's Petra. Thank you. Is it Didi?
Yes.
Yeah.
Didi,
Hi.
Didi Pershouse. Yeah.
So I was just having a lovely conversation with David in Woodstock, and he's a chef, and I completely agree with his thoughts on this. He was mentioning about nutrient density as opposed to the yield gap and the hype around how we're not going to feed everyone, and just how kind of industrial, that is my understanding of what he said, and he can correct me, but industrial methods and large scale might not sort of, it's quite wasteful in terms of energy and therefore contributes to climate change. Yeah, thanks.
Yeah, thank you. And Mary Cade or Cade, I see your hand up. If you were wanting to speak, feel free to unmute. Okay, maybe we'll come back. Maybe her hand was up for another reason. Anyone else? This question about how do we think about climate change? How do we frame the issue? What are our aims? How are we seeing things a little differently? Maybe hear from 3 more people. Feel free to just unmute and jump in because I can't see everyone.
Hi, Didi. I sort of stayed pretty much in my mindset, so I don't know if that's a good thing or a bad thing in there. But I just get, I want to see a lot more water. I want to see a lot more wetlands, and I want to see the extensive field drainage systems that are bleeding the soil and carrying sediment and nutrients out of it into the water courses. And yet, with planning and everything else, it is just a devil of a job to get these things off the ground in the UK.
Can I just say, I live,
Tony.
I live in Somerset in the UK, very close to an area called the Somerset Levels. And historically they were flood meadows. And over a couple of centuries, they put large drainage channels in. And now so many of the farms do flood naturally, but there's so much drainage that we now get excessive flooding. And lots of people ask the government to come in and dredge even deeper and deeper and deeper in order to try and get rid of the floods. And of course, that's the backwards solution.
Yeah.
Mark, yes. And Mark, I know previously we couldn't hear you well with your video on, so you might turn it off just while you're speaking.
Turn my video, okay.
Yes, we'll hear you better.
That's quite interesting because I actually farm on the Somerset Levels, and what the previous speaker has just said is that what happened was the Environment Agency decided to stop dredging the rivers, and that's why the flooding occurred. Because historically the rivers had been dredged lots, but in terms of responses to kind of global warming, we should actually not be talking about those things, because economics actually makes many of the responses the default option now in terms of renewable energy, especially in the UK, things like wind turbines, preferably on land, is that as soon as you talk about environmentally sustainable responses, people think that's going to be expensive. We should talk about what they're interested in is sustainable jobs and things. It's not talking about that. We're talking about what is good for them and their children. The environment will come as a default, a positive externality. That's what I believe.
Thank you. One more person. Any particular thing, like what's a new aim that you have? Someone who came out of that question with a new aim.
I'd like to.
Great.
I dominated our little breakout room a bit. I'm sorry. What I want to do is ban artificial fertilizers, because throughout this conference we've been hearing about all of the harm that they do to the environment, to the health, to the soil, to the growing methods, to the plants that are grown within them. And so the language that I use is just to get rid of I can't, it just seems awfully simple to me. If you take them away, then all the farmers have to learn how to farm more regeneratively and more organically, which will help to solve everything, in my view. And then you get lovely land that absorbs lovely sponge soils and look after the soil, and the creation of water as well, and from all of the things that are growing and aspiring, and is it aspiration? Respiration. Yeah, so that's my language, is ban them.
Thank you, Carol. Yes, that's actually a great lead into the next thing here. So, okay, and Dora, maybe if you could share those links. Someone had asked about links to the project in Andhra Pradesh, and Dora now has four different things there. So just keep your eye on the chat if you wanted to click through to those. But if you click through to a video, don't start playing it with your volume on, please. Thank you. Okay, let me go back to my screen share here. Okay. So I want to talk through these 4 different ways of seeing a living system. And these are from the work that I have done in the change agent development community with Carol Sanford. This is a framework that she's passing along, and I'm lending it to you for today as a way to check your own thinking, and just kind of to test your thinking as you start talking to other people, as you're writing, as you're making decisions. So one level that we're very familiar with is extracting value from a living system. And I just want to say, we all are prone to all of these ways of looking at a living system throughout the day. Any one of us can fall into any of these. And the idea here is to be conscious of what level you're viewing the system from, so that we can keep kind of elevating our thinking and moving it forward. So extracting value from a living system is quite familiar to many of us. And the next one that often leads to, for those of us who want the world to go well, is something that Carol calls arrest disorder, which you could also say stop the chaos or stop the damage. It's a pushing back against this value extracting mentality or view. So it's banning this or stopping that or fighting that. And a lot of good policy has happened at this level. A lot of people have put their lives and their work on the line in order to stop bad things from happening. However, the challenge here is that energetically you are in fight mode, and as the harder that you push, the folks who have control will push back. And so it doesn't mean it's not worth doing. There are times where it's absolutely necessary, but to understand that there's a lot of energy required to be operating at this level and keep it up. It's exhausting, and it may or may not have the outcome that you want because of that constant pushing back issue from the lower level. So what a lot of projects are trying to do now is to move to a higher level of doing good. So rather than taking the energy to push backwards, say, let's just get food out to people. Let's dig wells. Let's feed the hungry. Let's empower women, etc. Super important work. Many foundations are putting their money into this. The only issue here is that my idea of what's good may be different than yours, so we don't all necessarily agree on that. It can lead to sort of funding fights between my department and your department. And the way our economy is set up right now, the money for these do good projects tends to come from the extract value economy. So the foundation money is often, there's money there because someone's extracting value somewhere else. So it's not necessarily fully addressing things. So what do we do? What other view can we take? Well, a fourth way of seeing a living system is seeing it as something where you want to regenerate life. It's no longer, it's not extractive, it's not pushing back, and it's beyond doing good. It's doing good plus in a way that is really taking into account the whole system. So to regenerate life, if you really hold yourself or your project to that level, you can't fully regenerate life if the money is coming from an extractive system. And if you're feeding the hungry, it has to be in a way that you are developing the capacity of the community to do that long-term themselves, not just handing food out, though that may be very important in the short term. So, like right now with COVID, we have some hard choices to make because, of course, our food system is certainly interfering with people's ability to, for their immune systems to regulate themselves. But we may, depending on who you talk to, may well make sense to try to stop the damage that's happening. But how do we stop the damage that's happening without it being an extractive economy? Where is the money coming from and going to? How do we do good in this situation in a way that regenerates life? So you can see that different aspects of a project each need to be taken into account. We can apply this to any living system. So as a parent, you can apply this to your child. Yesterday, those who were at my talk yesterday, we started off with an exercise looking at a child that you care about. And to what extent are you wanting things from that child, that they're going to take care of you when you get old, or they're going to cheer you up when you're unhappy? To what extent are we trying to stop bad things from happening to them or stop them from doing things that are dangerous? Where do we want to do good things for that child? And how is that different than looking at them as a whole living system, a whole living being, totally unique, just like your watershed, your water catchment is different than mine. Your forest is different than mine. Your farm is different than the person next to you on the screen. So how do we see that child, that farm, that watershed as a whole that is nested within other wholes, that is has endless potential and capacity for development if it is seen, if it is given the right conditions? And how do we create those conditions where regeneration starts to happen naturally without our having to put a lot of energy into these lower three levels? So I did that exercise about how do we think about and talk about climate change, because so much of climate change has been focused on buying the right things, different light bulbs or cars or solar panels, on stopping, fighting the system, on drawing down carbon as if carbon was something bad, which yes, drawdown is a very key piece of this, but the language that we use around carbon is different than saying carbon is life and it should be in living systems. How do we create more life versus how do we draw down this bad thing? Just putting this out there to push a little bit, to push you into thinking, reevaluating, keeping your language really front and center as you talk to other people, as you think about ideas. So I'm going to throw out some other thoughts here. That the soil sponge is one way of thinking about it, is that it's foundational infrastructure for life on land. It provides many goods and services, if we think of it kind of in economic terms, and it underlies all successful human economies and societies. Humans cannot build the soil sponge. It really requires a diverse biological workforce. And this biological workforce, like any workforce, needs good working conditions. So acceptance, welcome, and respect for a diverse workforce, food and water year-round, protection from the elements, protection from toxic chemicals, the capacity to be self-organizing, trusted to make their own adaptive decisions, and payment in a currency that they can use and reinvest. So we think about these payment for ecosystem services in initiatives, which I'm on our state's working group on that idea. And that's all well and good about how do we hire a farmer to grow a soil sponge, but also what is the currency that the plants need? What is the currency that the microbes need? If damage is done, how is that going to get repaid? Is it just that the landowner gets paid for some damage that was done to his or her land, or does the biosphere get repaid in a way? So this is one question that I've posed to a lot of policymakers, is which infrastructure are we going to spend our money and time repairing? Are we going to spend our time building more dams and reservoirs, piping water to more different places and repairing roads? Or are we going to spend our time and energy and resources repairing the underground infrastructure that makes all of that above ground infrastructure really unnecessary? So that's a choice we have. And depending on how we frame it, the language that we use, the energy, where we put our energy, the outcome is going to be different. This is a quote from a close colleague, Peter Donovan, who founded the Soil Carbon Coalition. The issue is that over vast areas of the world, the biosphere is not doing enough work. With livestock confined and crop monocultures dependent on fossil fuel energy to maintain them, too many of the animals are in prison, too many of the plants are on welfare, and too many of the microbes are dead. So another frame that we can look through, one is sort of soil as a biological workforce. Another is thinking of soil as a living system, much like any other being. And the health of all life on land is nested within that health of the soil. So I've circled down at the bottom here that healthy plants can become completely resistant to diseases and insects. And you'll see that when plants are growing in a regenerative, and that word means so many different things to different people, but growing in a system where their capacity to photosynthesize, their capacity to share nutrients with other beings in the system, other plant families, with microbes, with all of the underground life, then really interesting things start happening in terms of their immunity. And we see this in the Andhra Pradesh system, where plants are becoming resistant to lots of different pests and diseases, and more resistant to wind and wind damage and rain damage, etc. because they are able to create more and more compounds within their own bodies. So this is a little hard to read, but you'll see that what's happening here is that as their metabolism is functioning in a more rich level, they are developing immunity to different kinds of things, both viruses and fungal diseases, but also different types of insects, etc. Now, this is absolutely equally true for everything that's eating those plants. Those benefits get passed along through the food chain. Another way to think about this is the soil sponge as a mucosal membrane of the land. It's providing a microbially rich, protected space for nutrient access and sorting, for respiration, for the immune response of the land and the plants and everything that's eating from it, for recycling of wastes and regeneration of life. So some specifics there, people here have probably heard of the soil food web, which is really just the plants are taking CO2, combining it with water and some nutrients from the soil, using solar power to turn it into themselves and then into exudates that they're feeding out through their roots, and then feeding all of the life below land and also all of the life above the ground. And mycorrhizal fungi are symbiotic fungi that feed off of, that are feeding back and forth with plants. So they are going out and searching out both hidden water in the soil, but also getting nutrients from other places and bringing them back to the plant in exchange for those sugary exudates. When the soil food web is working well, those enzymes that are created through all those metabolic processes turn on other microbes and wake them up. So a soil may have a lot of microbes, but they may not be awake and acting and eating each other and doing all of their work. Here's an example from Andhra Pradesh, and Doris is going to post in the link some of the videos, etc., in Facebook group where you can learn more about this project that I was talking about with 800,000 farmers in one state in India that's inspiring other states in India and the country of Rwanda, etc., to take up the same project. That you can see that the farm on the right that was using these principles of land management, that the plant stocks were much less likely to fall over. And this is just one, sorry, I have hundreds of other wonderful pictures that you can see some of them in the Facebook group of rice crops and all different kinds of crops after storms, and how the structural integrity, the cell membranes, the whole interior structure of the plant changes when they can get enough nutrients from the soil to make them more resilient. So this goes back to my talk yesterday that the pathogen is nothing, the terrain is everything. This was a colleague of Louis Pasteur who argued that really it's not about whether there's a certain bacteria or virus in the area, or whether the pests, whether someone can mute themselves who just came on, thanks. Whether there's something in the in our gut or in the air around us that that can infect us. The question is your terrain, is your microbiome, is your soil around you resilient? Yes, we just kind of went through these, but this idea of how carbon and nutrients and water cycle through the system, making food that's going through the whole system for every living thing. As above, so below. I love those two images yesterday I came across. I think that's kind of amazing. The how that's a plant root and exudates coming out to feed the soil life around it and creating that soil sponge. Those little threads you're seeing there are those mycorrhizal fungi holding together those sand, silt, and clay particles. And in a cubic meter of healthy soil, you can have 250,000 kilometers of these fungal hyphae that are all hard at work, looking for nutrients for the plant, finding hidden water that's stuck in these tiny little spaces, communicating between plants, and sorting and sifting those nutrients, keeping the toxins out and bringing in just the right ratio of what the plant needs in that moment in time. So there's huge communication going back and forth in terms of the plant's needs and the mycorrhizal needs, and they're basically this whole underground trading of resources, just like parents and children do, just like barter, economists, people trading things at a market, depending on how you want to frame it. There's a lot of different ways we can see this system. The soil food web, things are eating each other and moving nutrients through the system as things go back and forth. Sorry, this picture is a little blurry, but in a healthy soil, you'll see that there are actually, the soil is sticking to the plant roots. And that means that the bacteria right in the root zone are very active. The healthy bacteria. Oh, sorry, we got a little. So in terms of human health, when we think of an intelligent soil system, the place where we can find food that has those mycorrhizal relationships, for sure, foods grown in a healthy organic perennial system. So those may be the berries and things like that, wild foods, pasture-raised animal products. Those are places where the nutrients, we're pretty sure, have been intelligently sorted into these concentrations and ratios. And when we can get food from an intelligent system, then we know that that helps to maintain our own body's intelligence and immunity. And that's just an afternoon meal at my house one lovely summer afternoon with things that were all grown locally or collected locally. That blue one is a mushroom around here that it's the only blue mushroom, so you know it's safe to eat. Anne B. Clay talks about our own body's intestinal microbial interface being very similar to that plant root microbial interface, but turned inside out. So in our own bodies, we have a very similar thing of sorting nutrients and providing that immunity and sorting through things. So again, we can have that kind of intelligence in our own guts by feeding a diversity of food to ourselves. So for those who are thinking about how do we do this, I touched on this earlier, but these are some ways of framing some soil health principles. And basically we're answering the question here is, how does nature grow food and how does nature grow the soil sponge? So we provide that shelter and moisture and nutrition for the soil life by keeping it covered year round with living plants or mulch, depending on what your context is, where you are in the world. Minimizing stresses, so physical stresses like unnecessary tillage, chemical stresses, minimizing use of pesticides, and biological stresses, so minimizing either over or undergrazing, which are both possible stresses on the land. Oh, sorry about that. Let me turn that off. So using plant diversity above ground, which will increase biological diversity both above and ground and below ground, and then integrating a diversity of animals, welcoming them into the system as well as you can, to move nutrients, to provide and move microbes through the manure, et cetera. And remember, it's not just cows are not the only herbivores. Different insects and birds, et cetera, are herbivores too. To move seeds and pollen if you're in a perennial system, and to regulate water flows. So beaver and prairie dogs and various other animals can help with that if we have a large enough space to let them work in the way that they naturally work. And then really important is to get to know the context of the land, because what's appropriate or useful in one place may or may not be useful where we are. And this isn't just about only native plants, because one thing we know is that what can grow will grow, and that each plant family that comes in is making room for the next thing to be able to grow. So there's not much point in trying to replant older native species if they're not growing well now. You need to actually change the ecosystem of the soil so that they can grow. And to look, Nicole Masters talks about reading your weeds. So noting what is growing, and that can tell you a lot about the health and structure and function of the soil. And then you can find other things that you want to grow that would grow in similar conditions. And those will keep the soil structure and function and health changing over time. So when we, well, we already got that one, yeah. So best practices, I actually not so keen on this term, because this is what's happened in the United States with our best management practices, is that we have bare uncovered soils. We have, this is in the middle of June, when we should have huge amounts of photosynthesis going on, our longest daylight hours, and everything is bare, naked, hungry, thirsty, and running a fever, as Ray Archuleta says. So thinking about principles rather than best management practices is often a better way to approach things. So again, another way of framing this, which healthcare system are we going to invest in? Are we going to invest in the one that we are currently pouring huge amounts of money into? You know, in the United States, people spend something like $17,000 a year on their healthcare. Or are we going to invest in this one, in this, the foundation of our health, coming from the health of the land and coming from the health of the plants that are feeding us and feeding other things? Okay. Why don't we take just 30 minutes to, not 30 minutes, 30 seconds or a minute for people to type into the chat what you're thinking about now. And I will, when I'm sharing, I can't see the chat, so I'd love to just follow your minds here a little bit. So Caroline's asking something about reintroducing native plants. It's not that there's no point in reintroducing them, it's that we need to really understand where the system is at, rather than wasting time and energy introducing things into a system that would be growing them if they could. The seed bank is there, but if the seed bank is gone and needs to be helped along, absolutely, yes. So I also want to invite, if you do need to leave, to invite you, Dora, if you can post the link to a place where, if people are interested in doing a longer class on this, I've got some deep dive courses coming up, a number of different ones, one that's already posted online. If you can post the link both to the lolly.teachable.org, which has all of the current and past courses listed, but also there's a link to something that you can just sign up to be notified when we do get, when a new course is launched. So we have one coming up in, I think it's February 8th through 12th, that right now is listed at a time that would be a little bit late for the folks in the UK, but I may very well do a second session of it earlier in the day, if there's enough people from the UK that are interested. So, or from Europe in general. We just did one that was at a sort of Europe friendly hours. And so I was trying to hit the deep Pacific for this one, but okay, let's just go back to the screen share. I wanted to talk a little bit about how we measure things. And let's see if we can get to, there's a, oops. So, and I love to get everybody involved in measuring, because measuring things and monitoring things can help to keep our curiosity alive. So this is a group of young people just looking at how much diversity there is within a hoop. You can move from one place of the playground to another and see what's there. And looking at diversity of plants, but also diversity of any insects that they see. And then you can play around with pouring water right there and see, does the diversity have any impact on the water infiltration? Same thing we can do looking at the soil surface in a cropland. These are workshops that we were teaching before the pandemic hit. So this is setting up a transect for long-term monitoring that you can come back to year after year. Same thing here in Chicago, learning how to map and set up a transect in a public park near this high school. Sharpening water infiltration rings that then you can pour water, pound into the ground, pour water into, and time how long it takes to get down into the ground. And this is another thing that's super useful to track over time, how well your soil sponge is developing. But you can also, and it's a little hard to see here what's going on, but you can also do a test of bulk density, which is not hard to do with easy, cheap materials, to see, is the soil, is it getting fluffier over time? And also side by side, if you've got two different places you've been managing differently from one part of your farm or your yard to another, you can see the change in the bulk density from one spot to another. Measuring the carbon in the soils is another key piece of this, though. I just caution people. I started off super fired up about soil carbon, and in monitoring with this Soil Carbon Coalition across North America, we found that soil carbon levels and just microbial diversity and communities really vary from one spot to another very dramatically. And also how deep you measure makes a big difference in terms of what's happening 3 feet down. It may be that the soil carbon is moving upwards, because soil carbon is the living, the dead, and the very dead. It's the soil microbes are the soil carbon. That's a big piece of it. And they just move around and are doing things in different places, that it's not as predictable as people are making it out to be with these carbon markets that are evolving. Let's see if this takes, there we go. So this is a document that we're working on of different ways to measure the soil structure and function. So bulk density, as I measured, compaction, simple measure, just even sticking a shovel in the ground can help you know what's going on in terms of the soil sponge. Aggregation is whether the soil is more sort of crumbly like cake or less like flour or clay. Aggregate stability, that test where you saw the two different tubes and the water was the soil was sticking together in one and not in the other. Water holding capacity, so delayed onset of wilting. You can, with your house plants, you have a little sense of whether the soil sponge is effective or not. The green season lengthening, soil moisture being more consistent, the decrease of erosion, both wind and water erosion. The flow of nearby streams and rivers is more regulated, so less peak flows and low flows and more just regulated flow. So after a rain, the water gradually, like later, you might get a little peak, but it's not like a flash flood. Rootability, so the roots can go deeper and more branching. There are fewer just places where maybe a radish goes down or a carrot and suddenly goes sideways. So those compaction layers can start to break up. Less water running off. Algal blooms is actually, I've been hearing that an effective soil sponge isn't always necessarily going to decrease the algal blooms. So I'm intrigued about this particular one, that that the water being able to go down, it may also be moving sideways. So this is a vote for using less nutrients on the field, whether or not your sponge is healthy. The infiltration rate, as I was just showing, you can do that with a ring test, but there's also very expensive equipment that can measure it really, really accurately, called a dual head infiltrometer. Those slides I showed of puddling or ponding on a landscape in low areas after heavy rains, the soil moisture being more regulated, plant health and structural integrity. So we've gone into that quite a bit, the resistance to disease, and that also means a longer shelf life. And then some of those more obvious measures, the production in general can increase, but also the production per inch of rainfall, which is a really interesting measure. And then there's some satellite things or more weather related things we can see, like the increasing trend in the length of green season over a larger region as measured by the NDVI. Lower air temperatures during heat waves compared to surrounding areas. And then even just like the temperature locally in the soil. Oh, sorry, the link to that. I'm actually gonna put the link to that in the fact sheets page, which Dora can share. There's a bunch of, we're starting to put together articles and fact sheets with citations in them. So that Google Doc will be linked to from there. So I will try and do that later today. That's on the, Dora, are you finding it? Yes, perfect, thanks. Okay, just keeping an eye on the time here. Okay, for this last part, I want to have you do another little exercise to think of a summer week in the city with no air conditioning, and feel it and smell it and hear the traffic. And then think about what's the cycle of heat during the day and the night. What's it like to try to fall asleep at night and wake in the morning? What sort of a covering sheet or blanket do you use? And then you take off your shoes, go outside the middle of the day or first thing in the morning and then middle of the day and walk barefoot. Where do you need to jump? Where do you want to go when you're on the pavement? What do you feel? And maybe just post a few images in the chat as you're thinking through this. And then compare that image with a summer week in a lush green rural area of forest or meadows. Feel it, smell it, hear the birds. What's the cycle of heat during the day and night there? What's it like to fall asleep at night or wake in the morning? What kind of covering do you use at night? And then again, what's it like to walk barefoot in the first thing in the morning? How about during the middle of the day? And Dora, I don't know if you can recreate the rooms so people are in with different people. And we're getting down to a smaller number. And we'll just do, I'd love to do just a quick little breakout, like 3 minutes, just for people to share back and forth. I also, for folks who are leaving, let me see if I can.
Would you like the same amount of people, sort of 3?
So I think, yeah, groups of 3 would be great. So it might be we don't need as many rooms at this point. I do want to just, yeah, I just wanted to post in case folks need to leave, because I know the conference is you've got lots of different things going on at once, and it is getting later in the day for some of you ready for dinner. That this is that course that's coming up that we had people sign up very quickly for the last one, and everyone wants to continue learning. So a lot of them are probably going to sign up again. We've got it's not just learning, it's really developing a long-term learning community. And that's what's been so lovely about these courses, is people joining in the Google group and much longer discussions and very sweet relationships developing between people who can help think from one part of the world to another and test our thinking and work on projects together. So, okay. Jimmy, that's actually an online course. So, if you, Dora has a link to sign up just to be notified of things, and she can put that in there. So, and Hen, I invite you, if you don't have a camera or microphone, to just use the chat to go ahead and post your answers to those. I'll throw that slide back up with the questions. But really, we're just comparing urban and rural hot summer days. But let's get some real images in our minds as we think about this. So Dora, go ahead if you can break things out for like a 3-minute breakout.
Those pictures you showed at the beginning of Vermont, what's happened since? Has anything changed in the way people look at the landscape? Or
well, I think mostly what happened was a lot of bridge and road repair and larger culverts for the water to go through, which will actually speed it up even faster. I've been trying to get there are a number of us, because we have an annual conference here, a number of us who've been trying to get the word out about that speeding the water up and getting it off the land faster isn't necessarily the right approach. But for, New England, where we are in the US, in Vermont, we had all of the forests were cut down for sheep farming 150 years ago. And so we had a tremendous amount of soil slip off of our steep hills. And so there's rebuilding the sponge here is tricky because we have just a thin layer of soil over bedrock at the tops of a lot of the hillsides, which is true, I think, also in England, that it looks so lovely, but if you dig down a bit, it's not a whole lot there. So it's a challenge. Yeah.
okay,
So
thank you.
yeah, thanks for asking. So we're running short on time. So I am going to, let me just get through. We could hear from a couple people what you were thinking, but more I think more useful would be to go ahead and put it in the chat, so that we can keep moving here. Just some images to have in mind. And okay, so I just want to go through these two images as our last thing. Thinking about the climate cycle, that humans have really created our own deserts and droughts, and really our own, in many ways, we've created climate change, not just through our use of fossil fuels, but through our management of land. That human decisions have led to poorly managed soils and deforestation, that heavy tillage for even before industrial agriculture has collapsed the soil structure. And then this practice of bare fallow, leaving soil without any plants on it for long periods of time, means that there aren't enough plants feeding the underground life, and the soil sponge isn't being recreated. Then at the same time, both that soil being in the air from wind erosion, but also more pollutants, have created these warming hazes that trap heat on the surface of the earth. That humid hazes in some parts of the world really, really magnifying the effect of climate change. Then with the plants are making fewer of these, with less plants and forests, there's less of these volatile organic compounds and biological precipitation nuclei that are actually needed for clouds and rain to condense. To make something heavy enough to fall as a raindrop, you either need ice in the air, ice to be forming in the air, salts, which happens over the ocean, or you need these biological precipitation nuclei that come mostly from forests. So many areas actually have less of this sort of big puffy cloud formation and less rain. When rain does fall, it doesn't get absorbed, and that water moves sideways or it evaporates because we have less of the sponge. So then we have these heat developing on the land, and that heat and high pressure blocks the movement of weather systems that would be coming through from the coasts. So where the weather kind of collects, we have bigger storms, and then where the rain doesn't go, we have more severe droughts. The soil then erodes from wind and water, which like I was just talking about in Vermont, because we had heavy grazing and deforestation 100 years ago. We don't have much of a layer of soil there. It really needs to be rebuilt. It's just rocks with a little thin layer of soil on top, which I think is also true in many parts of the UK. Then, without that soil sponge to absorb the water tables drop and soil moisture decreases. And then the green season shortens. There's less transpiration, there's less cooling, and that's a feedback loop that goes back through this whole thing. And you continue, many of these things have been going on not just for 50 years or so, but actually for thousands of years. And so we really created that ourselves in many ways. So contrast that, and this is really, the first thing that I just went through is really that urban antibiotic or poorly managed rural landscape. But you could also think of it as a biotic climate cycle, and how landscapes can, under the right conditions and under natural conditions, create their own climates and their own rain. So here's how we can make rain and soil and good weather. Is plants, microbes, and other species create a soil sponge when we give them half a chance. That soil sponge soaks up the rain, preventing floods and droughts. The green season lengthens. That with that longer green season, we have more transpiration and cooling, via those latent heat fluxes. So it's kind of like sweat evaporating off of you, cools you, but it also cools the air around you. You may not notice that, but it is. And the same thing is true for plants. That creates these low pressure zones that develop over these cooler, greener landscapes. And those can then act as like a vacuum that's pulling moist air in from the coasts. So when you pull air in from the coasts, then you've got weather that's spreading out over continents. And there are the more gentle rainfall and more areas of rainfall, which kind of keeps kickstarting this. Then also, because if you have more forests, more diverse plants, more diverse grasslands, then these volatile organic compounds that the plants make and the microbes that actually live in the underside of leaves of forests, that go up with the transpiration stream can condense water vapor higher in the atmosphere to create these cooling clouds and to actually create water droplets, condensed water droplets that are large enough to fall as rain. This helps to disperse these humid hazes. And then at nighttime, this is what if we'd had a little more time, we would have gone into that urban versus rural. But I'm sure many of you have experienced it. At nighttime, you have this lovely cooling because all that heat that's gathered during the day, when you have a clear sky, because you've had a nice afternoon shower, rain shower, all of that heat can escape. And a lot of our global warming so far, I think 60% is nighttime warming because we have humid hazes instead of those clear skies. So then the sponge soaks in the water and slowly releases it. There's more moderate temperatures from the soil moisture that evaporates less water. There's more moisture in the ground. Plants can grow for longer, which grows a deeper soil sponge. And we keep going, and all of these things feed our feedback loops that keep things getting better and better. So I invite people to stay in touch and follow some of those links, share your thinking, and try out these ideas, test them in your own life. Evie from Scotland, thank you. That's a fun moment at the beginning of that Walter Jena lecture. I agree. So I would love to take just our last few minutes here to hear if we have like 3 minutes to hear people's response, what you're thinking, and post them in the chat. And maybe we'll just unmute a few folks who want to share them out loud. But I'd love to have you put them in the chat so that I get to read through them later. That's fun to know where people's minds have gone. So.
You haven't mentioned beavers at all, Didi.
You know what? Oh, here we. Okay, hang on. My last slide. We just didn't have time to get there, but if we keep going down, so there's these wonderful folks in Andhra Pradesh. There's that. Don't think that anything's impossible. Life is going to continue. And oh no, the beaver's gone. So there is a beaver. There's a beaver that usually ends things up. But yes, I have a lot of wonderful beavers around me, and they are very key to water flows. But I like to point out that the sort of permaculture idea of slowing and sinking water through creating barriers is one level, but we can create a million billion tiny micro dams through having living plants growing, and we can create a million tiny wetlands by having that soil sponge. So it's a bit of a mind shift from the humans needing to move soil around to letting biology move it around in, on a massive scale. Other thoughts? Edward McDonald?
Hi there. Yeah, just wanted to say that what you just said about the rainfall patterns resonates with my experience in doing some work in East Africa with water provision for schools, and I worked in two areas quite close to each other. One area is a tea producing region with very little forest cover, and they typically, had heavy rain every few days, which washed a lot of soil away in the rainy season. And the other area, just a little bit north, had the last section of rainforest there, and it rained every day, every afternoon, like clockwork. Not as heavily, but more gently, so the crops thrived a little better. So yeah, it resonates with what you say. I mean, I suppose in the UK we're more affected by the ocean, so perhaps that insight's more relevant to continental climates. But I guess even in the UK, I suppose I just wanted to ask a question about the role of trees, and because I gather in the US and Canada, you have much bigger fields with much fewer trees, whereas here we've got more hedgerows and copses. I suppose they play quite a pivotal role and potentially an increasingly important role.
Absolutely, and I don't think we know yet, other than from a few examples where forests have been restored and the rainfall has come back with the forest, about what's the density of trees that are needed, or does it matter what species they are, etc. There are some very clear examples of where rain clouds move through, rain on the forest, and then part to go around the big bare agricultural area and come back together again when the forest. That's in Australia. Look up the rabbit-proof fence, and you'll see what I'm talking about.
Hi, I don't know if you can hear. I've just unmuted myself.
Oh, sure, yeah.
Peter, just on that point, there's some farmers, I'm just trying to think of it, there's farmers in mid Wales that did a project where they changed the landscape through more hedgerow planting, reducing stocking and changing to more native breed sheep. And the season extended for grass either side of the wide hedgerows they were using. So that local climate changed, and the change in water management enabled the grass to come earlier in the spring and stay later in the autumn. So that's something we found in the UK works.
Yeah,
so
very interesting.
Reintroducing hedgerows into pasture systems can actually change the seasonality of those grasses.
Yeah, very interesting.
I think we have to end bang on time because someone else needs to come into the,
say goodbye.
the Zoom chat.
So yes, but I really encourage you to stay in touch. There, we've got lots of fun webinars, some things that are free, some things that are paid. I always provide scholarships to anybody who needs them for my courses. So don't be scared off by price tags. Just get in touch and stay in touch. And England is very, very near and dear to me as well. My family's from there and still have dear friends there. So thanks, everyone.